fact, if you use them for coding every day, you'd be like, yeah, it's incredibly useful. But the idea that it's the level of an expert software engineer is just a joke.
Yeah.
It could
Yeah.
become soon, but I don't think any experienced engineer using these things thinks that it's at that level now.
Yeah. Great.
I'll try to argue the other side a little bit, just to be fair and balanced. I think just to like set expectations, right? If you read an article just in the Wall Street Journal or the New York Times, just whatever major publication, it seems like pretty authoritative, right? Until it's a topic that you know a lot about. And then suddenly it's like, no, that's just not correct. And like no one sends in, anything specific to tech that like we probably know a lot about is just like very wrong, right? Like the way they describe it, the analogies they make, metaphors are just like very misleading, right?
Yeah. You convinced me, Michael, that the people at the New York Times are not AGIs.
I'll go ahead and
Okay.
register my prediction that things like this are generally overstated because the benchmarks are kind of bad. So when
Yeah.
someone comes out with a new thing and they're like, "Oh, it's almost as good as these ones on this benchmark," I'm like, "Yeah, but none of these benchmarks are that trustworthy."
Hello, and welcome to episode 3 of the Forward Pass. This is our monthly show where AI entrepreneurs cut through the noise, and we are all building products at the frontier. And every month on the show, we'll share real challenges, technical insights, and unfiltered takes, no filter here, on where the industry is actually headed. So if you're building with AI and LLMs and you want to sharpen your craft, this is the show for you. So let's get started. So this month, we've got a couple of fun topics. We've got a new benchmark that came out that Dan wants to introduce us to, and that is one of the first AI agent benchmarks as opposed to just LLM benchmarks, which I think will become increasingly common. But Dan has released something on the cutting edge of that. We're going to talk about a lot of the new model drops. I mean, it seems like every week now there's new models, but this month I think there's been about 5 or 6 pretty big model drops. So we're going to talk about those and what they mean for the trend. We're going to talk about quantized models, particularly around Quinn, and one of their new releases that showed the power of smaller quantized models being very performant. And then we'll wrap up talking about observability and routers. So if you're familiar with things like Open Router and stuff like that. So that's the docket for today. Let's get started with Deep Research Bench, which is the new AI agent benchmark for web search coming out of Future Search, which is an AI startup that Dan runs that is trying to predict the future. So Dan, do you want to kick us off and tell us about that?
I do. Thank you, Tyler. By the way, when you say no filter, that's like an Instagram thing, right? Are we going to
If
talk
you
about
want to put one of those little cute dog filters on that makes you look like a puppy, you can do that if you'd like.
Yeah, I like the idea that there's a no filter podcast, as in there's some sort of audio filter, like you would have a filter on a video or an image. I don't know what that would be. It'd be
We're
weird.
talking about the filter between your your frontal lobe stopping you from saying stupid stuff. That's the filter we're talking about.
Yeah, what is that saying? Like problem exists between chair and keyboard or something? Yeah.
Right.
Yeah. Okay. Yes. Yeah. So I'd love to talk about Deep Research Bench. It's a benchmark that we just released yesterday in a paper that is so new it's not even on the archive yet. One thing I've learned is that there's kind of a delay putting stuff on the archive, which didn't realize until founding Future Search.
How
Um,
long is the delay? That's interesting. I didn't know that either.
Took us a couple of weeks last time. I'm not sure
Please.
why. I think it typically takes 2 or 3 days.
Okay.
Yeah. So, yeah, as you said, Tyler, this is a benchmark of agents, not just one-shotting LLMs. But in particular, it's a benchmark of how well agents work on the web. And to us at Future Search, it was kind of surprising that no one had done this before. Using the web with a chatbot is one of the most common things that people do with chatbots. It's either you like click search or click deep research, or it's just enabled by default. I think ChatGPT has several times had search enabled by default. And sometimes you have to select it. I'm kind of confused on that. Claude recently launched web search. Gemini has deep research, and Gemini has been good at search from the very beginning. So it could be as much as like a third or half of all chatbot queries have search enabled, yet there is no benchmark at all for how well chatbots do with search. Like, how well do they use the web? people have all sorts of opinions. When DeepSeek came out, DeepSeek was, the agentic thing was using search. That was the main thing that people used DeepSeek for, was using its agent, tool use flow to use the web. And some people said it was great. Some people said it was terrible, and no benchmarks had any concrete data on this whatsoever. So we decided to make one, and we did this basically by making giant databases of stuff on the web. The main challenge with this, of course, is the web is ever changing. So if you give one query and then do it the next day, you might get a different answer. And that might be because the web changed. There might be new web pages might have gone away, or they might have changed. Also, search engines change every day. If your web agent uses like a Bing or a Google query, you might get different results one day or the next. So that makes it very hard to make an isolated, hermetic test environment where you can just run the same thing over and over again, or run two different agents. It'd be pretty sure you're getting the same, environment, so you get a fair comparison. So for all the questions in our benchmark, which are things like, compiling data sets and finding numbers and validating claims and gathering evidence and things like that, when we created the question, send out a bunch of web research agents to try to find some, anywhere from like 5 to 50,000 web pages that would be relevant for the answer, and just, scrape them and store them in a database. So now when an agent attempts them, you have those 50,000 web pages. So you can really do real web research, except without the real web. Yeah, and so we're quite happy to have this, because it, as a developer, it gives you a sense of how well using a model will work agentically, which is, there are some other agent benchmarks, not very many of them. But mostly, if you're ever just using something and it's called search or deep research or something like that, to have a sense of how good that thing is. One of the most surprising findings for us was that O3 with search enabled is dramatically better than OpenAI deep research. Like, it's not even close. In fact, O3 plus search is just the dominant web agent. It is very, very good. It has it's like quite good at certain capabilities that other tools can't even get off the ground. And Gemini 2.5 Pro, I think, is widely considered to be nearly as good or as good as O3 as a model. But Gemini 2.5 Pro driving web agents is not as good. And especially in the UI, if you just go to Gemini, have it use search or deep research and expect it to do some tricky thing, like especially if the information you want on the internet is not just obvious and not on the first set of Google results, Google is way far behind OpenAI. And this is a pretty surprising finding for us.
One thing I was surprised by looking at the results was that Gemini Flash was actually significantly higher and near the top. I think it was like fifth. Whereas 2.5 Pro, which based on cost and latency, is clearly a bigger model, did worse, like significantly worse. So do you have a sense for why that was, or did you guys dig into that at all?
I mean, this is hard for our listeners because they can't see the paper and look at which table are you looking at? I think Gemini 2.5 Pro beat Flash in all of the different evaluations we had.
Oh, did I get that wrong? Maybe I can scratch this from the final. Just cut out this.
Yeah, we did find that Gemini 2.5 Flash is a pretty good model. Again, so if you're using it as a web assistant, that's a pretty common way of using an LLM. So you can kind of look at any benchmark like this and just kind of squint and say, well, that's just how good the LLM is in general. It's kind of like asking like a math benchmark or a science question benchmark. It's a pretty good signal of how good the thing is, although generally people aren't using them for math and science questions. You're much more likely to be using it for web research. And so for this, I think you can just kind of glance at it and get a sense of how good these things are. But yeah, the top level finding was, Gemini 2.5 Pro, Quad Sonnet 3.7, and OpenAI O3 are in a class of their own. And GPT 4.1 and Gemini Flash 2.5 Flash are kind of the second tier. And then everything else is much worse.
Okay, it turns out I'm just very bad at reading charts. I don't know why I got that wrong. Okay, that makes more sense, because I was going to say, like, if that's the case, then it seems like there's some like highly non-correlated skill with like just raw power. Roughly, this like lined up with my sense of like which models are better at other things like math or all the other things you have really good benchmarks for, except for that one call out, which I don't know why. I think I was just hallucinating or something. But that actually makes me feel a little bit better. Makes me feel a little bit better that like it seems like the skill sets are highly correlated, and including this very complex, novel skill set that you guys had them do with the web search, it seems highly correlated with their abilities in general.
Yeah, and I think that's definitely true in our qualitative reading through all of the results. But also, I think we were kind of surprised to just see how dumb the models still are. I think using them conventionally these days, they generally do so well and they generally know about as much as you do that it's very hard to catch them confabulating or hallucinating, lying. I mean, people do find them doing things like that or just making gratuitous judgment errors, like just making boneheaded decisions, like believing like clearly incredulous data or not even knowing how to use their own tools. You just rarely catch these things in the wild. And so we kind of get this impression that O3 and Gemini 2.5 Pro and Claude Sonnet 3.7 thinking are like AGI, or it kind of feels like they're just general intelligences that can do anything we can do. But if you just look very carefully, like you kind of work through these tasks. So one of them, for example, that we have the most instances in our eval set is a task called find original source. So you take a claim on the web, and the task is find where this originally came from. Um, it's pretty easy for humans. You just kind of take snippets of the thing and just Google it, and then just read, and you see it somewhere else. You take a snippet of that. It says, you get hints when things are, even if they're not directly cited, you get hints of where things came from. Humans can quite reliably get to the bottom of this. The best agents struggle mightily and make all sorts of dumb mistakes. Just making conclusions like a clear, second party news source like SEO spam aggregator thing and saying that's the original source of some claim where there was no chance that that source like actually did any of the research behind. Like any human would tell that that's where that originally came from. But O3 will quite confidently assert that it came from there and finish its agent loop and say, great, I've definitely done my job. And you look at it and you're like, well, because I carefully worked out the answer to this myself, I can tell you're being stupid right now. But if you use O3 plus search on something where you don't already know the answer in detail, it's very hard to catch it, and it looks quite compelling. So I think one of the main takeaways from this is that these things are still not human level. They're very good, but they're far from like a careful human who is actually checking their work. Another interesting result from this was that the hallucination rate has seemingly not dropped as models have gotten better. People have talked about O3 hallucinating a lot. We couldn't quite confirm that in this paper, but we overall don't see the hallucination rate dropping. The main difference, we've got a table in the paper that's all the different mistakes that it makes. It's like tool misuse, gullibility, missing the point to something. Forgetting is a big problem. You guys remember the era of like catastrophic forgetting with our LSTMs and just trying to keep all the information together. Agents will still lose track of what they're doing and like get misled by something and kind of mess up. That still happens and we catch it all the time. Things that seems to be decreasing, like longer context windows and just better attention mechanisms. I think models kind of just forget what they're doing a lot less now than they used to. But kind of basic reasoning mistakes and hallucinations are not as common. I think the main thing that is better with models is really is just they're more intelligent overall. Like they are cleverer in their strategies for how to search for things, but at each individual step, they still have like a pretty high rate of doing something boneheaded that no human would ever do.
Yeah, I think anyone who's used the coding agents, like in Cursor, even the top, like Max, the ones they call Max, um, they just make dumb mistakes constantly. So I wasn't under the impression that we had AGI yet either. I think if you've ever used the models to try to push something where you're an expert and you're trying to push it past its limits, it's pretty clear that it's not. Like it has certain things that it's superhuman at, obviously, like typing speed, for example, is an obvious thing that's better than us. Um, but there's kind of like it's almost like when you have a boxing match, it's like the tail of the tape, which is like their skill sets and like their knockout percentage or whatever. Like, I feel like if you did that, humans versus AIs, like there's certain things that they're clearly way better at, but then there's other things that they're just like not even close. It feels like a pretty even kind of, if you took like the top 10 things you care about, like it's kind of a 5 and 5 humans versus AIs type of thing at this point. But a lot of the skills seem to have not changed over the past year, even, where like the things that the AIs are better at are still the same 5-ish things, where it's like obviously they're way faster, obviously they never need to sleep, obviously you can clone them, and they're way cheaper, all of those things. But like the actual things that humans have a lead on, like being careful or like validating a source authenticity or things like that, it's like humans have been always ahead on those, and it doesn't seem like they're starting to catch up yet. So I don't know what that implies, but that's my take.
Yeah, I think that's absolutely right. And the listeners are builders, and I think builders know just how fragile these things are, even as they appear to be getting better and better. All of their weaknesses. If you're working on image models, you're going to see some bad images. Working on audio, you're going to get some garbled text. And like people who are building these things know this. but I think the general public is maybe over optimistic, and especially for things like math benchmarks and like science PhD questions. Those are by far the most commonly referenced things. Are at the top of every scorecard for every release. These models are ridiculously good at answering multiple choice science questions, and they're really, really good at math. And I think it's very easy for people to infer that they're good at things like coding. But in fact, if you use them for coding every day, you'd be like, yeah, it's incredibly useful. But the idea that it's the level of an expert software engineer is just a joke. It could become soon, but I don't think any experienced engineer using these things thinks that it's at that level now.
Yeah, great.
I'll try to argue the other side a little bit, just to be fair and balanced. I think just to like set expectations, right? If you read an article just in the Wall Street Journal or the New York Times, just whatever major publication, it seems like pretty authoritative, right? Until it's a topic that you know a lot about. And then suddenly it's like, no, that's just not correct. And like no one sends in, anything specific to tech that like we probably know a lot about is just like very wrong, right? Like the way they describe it, the analogies they make, metaphors are just like very misleading, right? But I think like if you didn't work in tech and all your friends worked in tech, right? It's like it wouldn't register, right? I think like that's true for probably people in finance, right? Like just across different areas, if you're an expert in it, it instantly seems wrong. But if you're not an expert, it seems like, oh, that sounds about right. So I think there's some of that going on too, right? Where you're anything you're an expert in, like coding, right? It's like I know the right answer here. But for things that are more obscure, it does feel a little bit like magic because it's above the threshold of what you can verify yourself.
Yeah. You convinced me, Michael, that the people at the New York Times are not AGIs.
Well, I think it's like the problem is twofold, right? It has to be correct, which is hard, right? As like a busy journalist. But then it also has to be explainable in a way that's helpful for someone just like riding the train and like doesn't have a full, that doesn't have a ton of time to like go in and like do the original source research, right? So I think like the responses from these things have to hit a certain bar, right? It's hard, right? It needs to be explainable in the same way or interpretable, right? But it also needs to be correct enough. Uh, and obviously, there's a ton of issues right now, but I think there's also a lot of areas where it does seem like pretty magical because we're not an expert in those areas.
Right. I think where we're at is that it's somewhere between a journalist at a top publication and like an actual expert in a field. Like it's somewhere in between that, in my sense. I definitely agree it's below the expert level, but it does seem better than like your average Washington Post reporter or something.
Yeah, and I think that's something to keep in mind, right? Because it's not, you don't it's not easy to talk to experts, right? Because it's like a professor who invented whatever thing had a huge impact on the industry. Like they don't want to talk to you if you're an undergrad, like you barely know linear algebra. It's like what are you going to talk about, right? um, so I think there's some of it of that too. A lot of this, of course, changes if it's like AIs talking to AIs, and we don't have to like be the ones that are interpreting the results. But I think until then it's like we're kind of in this weird place where we can only evaluate things from our perspective, and sorry, each individual human that evaluates it does it from their like position of knowledge and expertise.
Right.
Well, part of the reason it is that way, I think, is because we don't have good evals for humans. So why is the Wall Street Journal more credible than the New York Times, which is more credible than the Atlantic or whatever the ranking is? It's entirely reputation based, right? There's no sense whatsoever that somebody's like keeping track of how many errors there are per sentence or per article. But when people make egregious mistakes, or if you read something that you see is obviously wrong, you're less likely to read it in the future. AIs are kind of like that today, where how good is one coding agent versus another? How good is Gemini 2.5 Pro versus Sonnet 3.7 in Cursor? I mean, there are some evals of that, but they're not very good. Basically, people are going by reputation and their own personal experience. But AI is ultimately much more intelligible, or I should say interpretable. We can build benchmarks and kind of pin these things down in the way that you never would be able to with the professor at a university or a journalist. And I think it's just a good project to do, but we have to kind of shift our mindsets around to demand more information. And the way that you can't realistically demand that your journalists like say, okay, show me all of your articles and tell me your error rates. Like they can't comply with that. The professor
Right.
can't tell you like, I mean, you can't get that information. But I think we should demand this information from our
Right.
AI systems, and people should sit down and study and measure these things. And the reputation should be more based on objective merit than they are of like, well, my friend said he tried this image model and it kind of made a nice image for him. That will never go away. That's still important. But I think objective evaluation, intelligence is more measurable now than it's ever been before because it's software as opposed to in our brains. We should take advantage of that and kind of change our norms around that.
That's a really good point about measurability. It could be just like an interesting side effect of AIs getting smart at a lot of things is that we think about evals for humans more than we used to, um, in domains where we didn't usually used to do that. Like for example, if someone builds like a very elite level legal benchmark that's very quantitative, you can then apply it to your average paralegal and see who's actually doing better. Whereas like before that didn't exist, right? It was just like, oh, I like this guy because he like we chit chat well at the coffee bar. I don't know. I don't know how lawyers evaluate each other, but it's much more vibes. Um, Chris, do you want to jump in on research before we move on, or just move to the next one?
Uh, no, I guess like definitely agree with you guys. I one example that was running through my mind when we were talking through it was even just on the coding side and building things, it's like the advantage that you see with these AIs that is super helpful is like I find myself no longer having to like pour through documentation for like a new SDK or there's it's kind of like a combo of like, oh, it's an SDK I don't know and a language that I'm not an expert in, and so you use a coding agent and it seems like magic because it knows all of it already. It's like read the docs, it gives you code in a language you don't know, and it then feels like magic. But it's like, yeah, if it's a language you're super used to and platform you're an expert in, that's when you start like picking it apart and you start seeing the flaws. And so it's yeah, I think even on these things, it's yeah, it was just kind of like a example that I've seen in as we build things.
Okay, cool. Yeah, that's a good like synthesis. That like it's not at the point where if you're a true expert, it's better than that, but it's for non-true expert. It's kind of like reminds me of like you think you're looking at the whole world in the room, but really your eyes are only looking at like a very tiny slice of that, and you kind of just hallucinate the rest of the room. Kind of is like that, where it's like when you're not looking super closely at it, you're like, wow, this research paper is incredible, but then as soon as you like really know something, it kind of becomes it looks blurry once you like have good vision or something like that. Okay, awesome job with Deep Research Bench, Dan. We'll put the link in the show notes. And if anyone in the community is listening, let's do more agent benchmarks rather than just kind of single LLM call type of benchmarks. That's going to be increasingly important. I mean, it seems like we're almost like saturating every possible benchmark for single calls. So agent benchmarks are the new frontier. Let's go brief on this one. I think it's not super important news because like every month there's new models, but if anyone has any take on all the new model drops, so we've had Llama 4, at least the lower two versions of that. I think they're still working on like the top two, like the big ones, but I think those are coming soon. So we've had Llama 4, we've had Quinn 3.1, we've had O3, we've had Grok 3 as an API. I'm probably forgetting one or two, but there's been a lot. GPT 4.1, which I don't know what they're doing with their naming over there. 4.5 already came out, and then it's 4. Like what is going on? So I don't know, but GPT 4.1 came out. I guess the question I would pose is like, are there any surprises here? My sense is like we're kind of just riding this curve down. Labs are starting to specialize, like for example, Anthropic's doing more coding stuff, and other ones are better at writing or blah blah blah. But so there's a little bit of specialization, but like basically we're all just riding the curve down. Doesn't seem like anyone's like moved the Pareto frontier much, as opposed to just like everyone's like exactly where you would have expected them to come out in terms of quality, like based on where they were the last three releases, and then just like linear interpolation. Like, I don't know. It seems like we can kind of predict where everyone's going to be in a year from now, almost based on the past 2 years. Does anyone disagree, or was anyone like surprised by anything?
I think I'm surprised a little bit by the lack of new non-thinking models. So GPT 4.1 would be the newest non-thinking model, and it's about as good as Gemini 2.5 Flash non-thinking, I think. Um, Maybe not quite as good as Sonnet 3.7 non-thinking. Now, to be fair, I'm the outlier here. I think most people predicted that's basically the end of non-thinking models. Like they're as good as they're going to get. There never will be a GPT-5. If you want models that are more capable, they need to do, inference time stuff. You've been talking about this for many months. We've talked about it on the show before. I was kind of a holdout. I really was expecting GPT-5 or Claude 4 or Gemini 3 or something as a model that can respond within a few seconds to your query and be as smart as a thinking model. I think I still predict that will in fact happen. There will be some, there were $50 million training runs. I think there will be a $500 million training run. I think it's what Llama 4 was supposed to be, but seemingly they failed because who knows? I mean, maybe it takes multiple iterations to get it right. And when you're at $500 million per run, and get that many iterations. I still think that the GPT-5 class model is possible and will be built at some point. So every time that doesn't happen and the frontier continues to be thinking models, that is a bit of an update for me, especially compared to where people were thinking things would be last year or the year before. But if I'm wrong, and I think the general crowd is right, it's kind of the end of raw LLMs. We're in the thinking regime where things are more specialized. And yeah, I think we're on trend. And I would agree, Tyler, like we're kind of mining out things, basically kind of extrapolating at the rate of the various, the inference time scaling laws. There's a new meter time horizon law, like, what length of task can an agent do measured in human time to do that same task. And we're just kind of expecting these things to go along the curves that people have already found.
Yeah, we'll see what happens with Llama 4. I generally agree. Llama 4 Behemoth is the one that they haven't released yet. That's their biggest one. It's like a mixture of 10 experts, and they're each like 300 billion or something. So it's like almost 2.5 trillion parameters. And basically, the way Zuck described that is like they're using that to distill. Like they kind of push the limit there, and then they're using that to then distill into the smaller models, which I think is a general pattern that we'll see because distillation has been such an effective technique to basically like it actually makes me the fact that distillation has been so successful makes me more bullish that we will get the very, very smart, very, very expensive to train model. Because I think one of the reasons people are like, we'll never get it is because it's not useful because it's so much inference cost that you can't 100x the inference cost before no one uses it anymore, or the latency. But what it means is that if you get that incredibly huge behemoth type of model, and then you can distill it down into a much more inference friendly size and get 95% of the intelligence for 10% of the price at inference, like that makes the economics of training that huge model worth it. So that does make me bullish that we will at least at some point see it. But 10x is a lot. I mean, 10x from 4 to 5, that's a lot. And then we're going to have to 10x again to get to 6. And it's like, wow, that's going to be really a lot. So, logarithmic scaling laws are logarithmic.
Yeah, and people have tried. I mean, we had GPT 4.5, which was just bad. And then we had Claude Sonnet 3.5 Opus, which Anthropic announced they were training and then just never released, presumably because it wasn't very good. Then we had Llama 3. It wasn't called Gargantuan Behemoth. I forget what it was called. Goliath. It was something big, and it was not very good. And then I think Llama 4, I'm kind of reading between the lines of Zuckerberg's interviews. I think if Llama 4 Behemoth, this 2.5 trillion monstrosity you mentioned, Tyler, is if it was expected to actually be good, I think Zuck would be acting like it's going to be good. But instead, he gets on these podcasts and he's like, well, the main thing is scaling to all of the Facebook use cases so you can use it in WhatsApp and stuff. I think he's very much thinking about kind of usefulness at scale and not actual intelligence. And my sense is because he already knows, and people at Fair, I mean, Meta has all sorts of problems that I don't really understand, but they're having a somewhat of a talent exodus. And I think the word on the street is that it's just not very smart. Like that's like kind of attempt number 3, at least that we know about, of a ridiculously giant model, and it just ain't that smart. So either they're not doing it very well, or there's some limit there, or maybe fourth time is the charm. Maybe Grok will do it. I mean, who knows? But people have been trying, and it's just not getting us the intelligence that, or at least for the cost that people are hoping for.
Yeah, I think the thing that Tyler, you and Dan had both pointed out is the cost aspect. I think the cost is hitting just the trading cost is hitting numbers that are difficult to hide now inside like R&D budgets. Like these are public companies, they have to have some justification. And ever since we've talked about this on the podcast, right? Like since the what's it called, deep seek moment, like people are maybe a little bit gun shy on like authorizing a $500 million spend for the next generation. Um, so I think there's some of that too going on where it's like, it's going to be an incremental gain. And it's like in a lot of ways, it's not proven that if you put in the $500 million, you'll get, more than that out. So I think there might be some of that going on too, where the level of interest is like waning a little bit because there are limits to high limits, but there are limits eventually to what people can reasonably invest.
I don't know. Some of the acceleration is, I mean, you could have made that same argument about the 50 million runs, like what got us GPT-4. People would have thought that's an insane, like $50 million for one run, and you don't even really have any evidence it'll be good. You're just hoping it'll be better. And then someone was crazy enough to actually do it, and then that kind of got us why we're on this podcast in the first place. And some people are like, yeah, 500 million. I mean, why not 5 billion? Like, if the returns are there, if there's even a 20% chance that you produce some new frontier model that is just smarter, and again, by not being an inference time model, just faster, like, and like being able to do something like O3 or Gemini 2.5 ProCamp at 10 times faster and 5 times cheaper. If
Right.
people thought they could do that, I feel like someone would be insane enough to spend the $500 million just to roll the dice and hope for the best. Like, I think Elon is crazy enough to do that. Zuckerberg is crazy enough to do that. Sam Altman is crazy enough. I mean, you have to be crazy, but I think these guys are demonstrating they really are that crazy.
We'll see. Maybe it's happened. Maybe it's signed off on, and it's just taking some work to polish up.
There's like 5 people who have the ability to say yes to those things, and yeah, Satya, and basically 3 you mentioned plus Satya and Sundar. Like those, it's up to those guys. Like it's way above our pay grade. I don't have $500 million to spend on it. So. Okay, cool. So Dan, I think you added this one about quantized Quinn 3 and the power of that. It seems kind of similar to this thing we've been talking about in terms of distillation, but basically it sounds like the result in the past day or so was that Quinn 3.1 came out and they were able to get to 98% of the quality of like the frontier models, but with only a 30 billion parameter model, which is like extremely fast and super cheap to run. Um, am I explaining that accurately, or do you want to take that one?
That wasn't me, and this is
Oh,
all
that wasn't you. Oh, who was that?
someone should explain because I'm curious about this one. I was not aware of
Who
that.
put that in the chat or in the docket? Was it Ray?
Was it? It must have been Ray.
I
It
think
wasn't me.
Ray dropped in our docket and then he had to go to the doctor. So I hope you're doing okay, Ray. We'll catch you next month and we'll catch you on Twitter. Maybe you can tell us about Quinn 3.1 in a month when it's old news.
I've registered
Okay.
my prediction that things like this are generally overstated because the benchmarks are kind of bad. So when someone comes out with a new thing and they're like, "Oh, it's almost as good as these ones on this benchmark," I'm like, "Yeah, but none of these benchmarks are that trustworthy." I mean, yeah, my company just made a new benchmark, and hopefully it's trustworthy. I mean, that's what we're trying to do. But generally speaking, we're still living in a regime where everyone has like kind of a raised eyebrow when they see results like this. So I'm going to go be bold on this podcast and say I don't think this is true. I don't think this is going to hold up. It's going to be one of these like training on the test set or just like over optimizing for multiple choice questions or like something that doesn't translate to like practical usage.
This is the type of unfiltered we were talking about, Dan. Cool. And Chris, do you want to start us off on the last topic in terms of observability and routers? So just to give context, observability platforms would be things that allow you to understand how your systems are calling LLMs, observe them. And then routers would be, I think the canonical example would be OpenRouter, where basically you take a single Python library, or if you're doing it through the browser, like a single browser window, and then you're able to give like the same query or the same prompt to like either any arbitrary model with just a dropdown, or even if you want, like you can just send it to all 5 or whatever, like do it to Perplexity, do it to Cloud 3, like do it to everyone, and then just like see all the results at the same time. So yeah, Chris, do you want to take that one?
Yeah. I think I'll start on kind of like the smaller topic of like the observability. I think in my experience, it's been uh, say like the providers that are providing like API access to a model, have like very basic kind of analytics or observability, and I've just found them a lot of times to be like really lacking in terms of even just trying to understand like how many calls you're making, simple kind of like stuff, because it'll maybe show you for like a certain time span, but it won't go back. And it's kind of like I get it. Analytics is like a whole business. There, it's like it can be a ton of data, and that's not like what they're trying to go after as their main business. So um, for me, I think like the better way to go has been to use kind of like these analytics and logging, platforms that have been around for a while that have, all of these like interfaces and queryability and everything. So that's what I've been doing typically is like, um, it kind of depends on the project of like, do say like, um, founders or product folks or anyone want, access to this in dashboards, and so then you kind of choose a tool for your audience, as opposed to kind of like the engineering side that may want more of that like monitoring and observability type of logs and things. But
Right.
yeah, so that's been kind of my experience is like basically don't rely on something out of the box from a provider, I guess. um, but it then kind of leads into the other topic of like there are these companies popping up and things now like say Open Router, another one I'd seen, um, Langbase, where it's kind of like a benefit of being able to um, swap out models easily, but then they're also kind of like offering this um, analytics and observability layer on top of it.
Right.
Um, and yeah, I guess it's kind of like new for them, but my general rule of thumb on this is like if that's not their primary focus for business value, then they're not gonna devote the time to make it really good. So I tend to go after like using companies where that's their like core focus. So, but I don't know if you guys have any take on the analytics observability side. Yeah.
Yeah, I strongly agree that analytics is hard and that if they're not fully focused on it, they're not going to be doing well. Maybe one thing I would ask before I give my little take is, Chris, like, can you name more specific examples? So when you said like, are you talking about like amplitude and mixed panel for like a better observability for like non-technical folks? And who are you referring to when you talk about like them being not very good and not being able to go back more than like a month or whatever? Like, call people out. Tell us who you're suggesting people avoid for the people
Yeah.
building out
Yeah.
there. Like, who should they not use and who should they use?
So I'll just kind of like name some of the typical, say, like API providers for that have like a variety of models for you. So like we'll say like Replicate or Foul or Together AI, Fireworks. These provide kind of like, yeah, we've got like a whole list of models. You definitely get some analytics, but I've found when you're trying to like connect the dots of, well, so like there's one really important question. It's like, how often is this are the models getting called, and like can we like what's the like per user kind of rate on this, and those sorts of things. And I've found that like all of them, you definitely get like a decent picture of like traffic for at least a week, but like some of them, if you try to go back like more than a month, it gets like combined. It's like here's your month. You don't have like a fine grained view into being able to go like day by day or week by week past like a certain limit. Um, and and I'd lump like some of the GPU providers in there as well, like RunPod and things like that, where
Right.
you're hosting your model yourself and you're using like a GPU provider and you're trying to figure it out.
So the TLDR is that inference providers and GPU hosters like CoreWeave or RunPod are not going to be good at analytics enough for you to most likely make business decisions that you need to make based on their analytics platform because it's not their core competency. Yeah, I strongly agree. I think that's a really, really good take, and I strongly agree with that. I think what we've done, and maybe this is like my advice to anyone listening, is I'm a big believer that like there is not currently, and I don't expect there to be a better like data solution than the relational database, which was like invented in the 60s and like just fucking works. Like we just put everything in Postgres. Like it's just great. And we just have a big wide table called LLM interactions. Every time we make a call, we just write a row and it's incredible. Like we can just do anything. We can just do like price per user, price per message per user, average price per provider over time, latency by well, like we could just do everything. We could be like, oh, this user had a higher average latency than it was like P99 latency, and that's why they churned. Like just any arbitrary question you want to ask of the data, like you just have it. It's like 20 rows or 20 columns. It's like user ID, provider, prompt, response. Was it a streaming prompt or not? Which model was it? The temperature we passed in, the response time, the token count of the prompt, the token count of the response, estimated cost in USD, when did it occur, and then a couple of like application specific things that help us like tie it to like specific like therapy sessions because we're doing therapy. And that's it. And like we just have that table. It has like for us like almost 10 million rows now. So it's definitely a big table because those prompts are long strings and stuff. And there's like some eventually there will be some like DevOps type of work that we'll have to do to like optimize the Postgres, query times and things like that if we start using it. But like it basically just like solved any arbitrary analytics question we would have over like around LLMs and how they're being used on the system. That's my advice, to just use Postgres.
Yeah, and it like with the advancement in like LLMs and some of the like connecting kind of like an agent, to your database and things, like you can now just query in natural language, right? Like, and
Right.
you can ask it to, reference or show you the SQL query, that kind of thing, but um, to double check. But yeah, it's
I suppose that's true that there is like a gap. This is a good solution for everyone who's technical and is going to want an answer to the question and is able to write SQL, even if that includes like asking Claude to write SQL, but they still know like how to execute it and they have database permissions and stuff. And so that is specific to that. I could imagine building a very simple like dashboard on top of that database for people who are non-technical. But for us, it's been sufficient because types of questions we have are detailed enough that we want to be doing things like projecting our unit economics over time and predicting, for example, like, hey, we have like 5 or 6 different like tasks in our backlog around like trying out new models. Like, should we try Grok 3 for like this particular job? And it's like, we can actually use that LLM interactions table to like prioritize for us and be like, okay, like what's the percentage of spend over time that's going to these different providers? Um, are the response lengths from certain providers like significantly different than others? And we can just like look at when we changed the model from one to the other and then just compare before and after and like look at like the histogram of response lengths. Like, so it's just like, I don't think, maybe I'm wrong. And if you guys know of one, let me know, but I don't think there's any provider out there that's going to be able to answer that level of detailed questions for you. They're all just going to be too abstract and not allow you to just actually like do bare metal kind of queries. So anyways.
Yeah, I plus one that. I use Lanesmith and we use Open Router and we use Light LLM, and then we also just dump everything into a Postgres, Supabase table and just query it. And we even have like our own proxy wrapping the other proxies because it doesn't have the features that we want.
Right.
Yeah, so I completely agree. It's such a fast-moving world. It's tough to have an abstraction, even if it's just logging or analytics or something, being used by a third party because like things change,
Yeah.
and then suddenly you're
Yes.
kind of out of luck. So I don't know. I mean, I'm kind of curious to hear from you, Michael, about Log10 and how this worked for you guys. But generally speaking, I feel like life is rough for these providers, and people are generally pretty unhappy with them, and people end up just kind of rolling their own.
Yeah, great. I think I'll argue about the Postgres thing later, Tyler. We can.
Do it now. Do it now. Do it now.
No. I think it's fine for this analytics use case, but I think with observability, especially with LLMs, I think it's a lot of it is a sort of a it's sort of a cop out, but it's sort of a what problem are you trying to solve? If you're trying to solve the like I need to aggregate metrics and like do a dashboard, I think there's a lot of ways to solve that. Rolling your own Postgres and just tracking the columns you care about. I think that's totally fine. There's also a lot of plugin dashboards now, like BI tools that's free. Um, Reset.io, I think, or that's one of them. There's a lot of reasonable dashboarding tools that can get you there quickly. And you just hook up your own Postgres. I think there's more to it now, right? That it's not just uh, gathering data and counting stuff or like, adding up your costs. There's also things like I want to trace this entire interaction all the way through. I want to see how much this interaction costs. I want to see like how long each one took in a little graph. There's also more in-depth things like, at this point in the interaction, I want to uh, I want to simulate a different response here and then see how it propagates to the rest of the interaction.
Right.
Right. So I think that's something you've talked about, Tyler, previously. Like, what happens if, like, somewhere in the middle of a therapy session, you wanted to like pretend it, like, a prompt deep down was like modified.
Right.
So that's a much deeper integration. There are tools for this now. Log10, it actually was, right? We've officially switched. Officially pivoted, but it used to be a LLM ops platform. So we were essentially, like all the different apps would all send stuff to us. The problems were like uh, twofold. One was like the setup was like pretty complicated, right? You have to like install an SDK that sends all the data to us, and then now we have all your interactions, and then we can show you stuff based on that. But on the cost side, you quickly become like Splunk, right? You have to accept a fire hose of data, of nearly infinite data. So now you have tons of problems to solve. You have to be able to serve it up quickly. You need to be able to have it be searchable. You need to do like compaction. You need to do all these things, live metrics, and things need to show up quickly. So you actually just end up with a huge infrastructure burden that's like pretty substantial. Which is fine if you get these massive like B2B contracts, but if with smaller players, like most startups are small and they're not generating that much traffic, it's like the economics are tough there. Um, yeah, the other thing is that it's actually just fairly undifferentiated. That's kind of the core problem we ran into. A lot of these are like, for example, like it sounds like two out of the four of us have implemented our own solution that's good enough for now, right? And then there's no off-the-shelf solution that is like the gold standard that just sort of works, right? For whatever definition works, right? Which is constantly shifting. So I think just like right now we are like we recommend like we are currently using Datadog's SDK for traces. They also have very scalable backends. You can like look back in time. Like they're not gonna they have the basic infrastructure problem solved. They're not gonna like lose your data. Data will the requests you make will show up quickly. And they're not a startup that's gonna disappear, right? I think they are a public company.
They are. They're worth
Yeah,
almost
so
100, almost 100 billion now, which is kind of crazy.
Yeah, they have very favorable SaaS metrics. They're just like very slowly building up their, subscribership. Um, I think there's
It's
also
36 billion. I stand corrected. Not almost 100. 36.
36. Okay. Um, we also recommend. I think Langfuse is also seems like to be building things in the right direction. They're like earlier stage, but they are open source. They seem to be like building the more like deeper LLM interactions, like simulate this, you know, traces and so forth. So that's worth looking at if you want to evaluate these. But honestly, I'd say like if you have a working solution right now, like I would just stick with it. It's not, I would say, of your problems, it is probably not like your most substantial one. And that sort of is like the final thing, right? It's like there's all these other things. Like most startups don't have evals, like most startups don't have benchmarks. Like it's sort of still a lot of people are in vibe check mode, right? Which is like the kind of the hypothesis of the LLM ops platform was like, oh, people are gonna rapidly shift out of that and like move up the value chain. But it's kind of happening slowly, I guess, is what we saw. Um, And was there anything else? I think that's sort of, yeah, there's like many different aspects. I could go on.
Yeah, that simulation piece I think is really interesting, Michael. Maybe we can talk about that in a future episode around how to simulate well. It's actually really related to like creating synthetic data and being able to do good evals. If you can't simulate like different tweaks and interactions, or be able to say like, hey, like what would happen if we changed something and kind of re-simulate what that would mean for our system at scale. I think that's like that is a separate thing from observability, although I see what you're saying about how it could be quite related and how an observability platform that's really good could facilitate that, which is something I actually hadn't thought about. So that's really cool. But yeah, I do think that simulation is an important thing for startups to be thinking about. And when you build your system, thinking about whether that it's going to set you up for simulatability, which I think is a word, simulatability. Um, one of the ways that we use this Postgres table is for that, because we're able to then basically just like, for example, get a notebook, drop like a random sample TSV file from that table, and then say like, okay, keep everything the same, all the parameters the same, but then just change the prompt to this new prompt that we're trying to push out, and then run all these simulations and kind of compare how the prompts were different or the responses were different. But yeah, I think simulation is like a really interesting topic that um, if your system is hard to simulate, I'm guessing it's going to be hard for you to like hill climb as a startup.
Yeah, I think that's a really important observation. I think it's also um like it's also in a lot of ways a different problem than and I'll tell you why. It's a different problem than the observability problem, and I think it's easy to mix them together because of like I think a very basic strategy for LLM ops platforms is like, oh, you integrate with us and all your stuff goes with us, and this is how we build our business. This is how we build our moat. Otherwise, it's very easy to switch, right? So
Right.
I think that's part of the problem. But I do think the simulation aspect and like a uh, generally eval, but specifically that simulation aspect, I think can be solved as a separate problem than like how much does O3 mini cost me versus, whatever GP4, right? So I think those are different problems, and I think in practice, it's uh, probably better to tease those apart right now um, until someone comes out with like the really gold standard solution here.
Cool. Well, yeah, great third episode, guys. Gonna wrap it. Does anyone have anything to say to sign off?
Oh, plus one for that being a topic for next episode next month. I'm quite interested in this. Like, get halfway through a trace, try to do something different, and then try to simulate if it would have gone better.
And then of course backtest that across your previous data set. So it's a tough problem. It's a tough problem.
Stay tuned, guys. Hit the like and subscribe if you're on YouTube. If you're on Spotify, then follow us. And if you're on Twitter, then retweet us to Elon or something. I don't know what Twitter does, but all right, guys. Good episode. Bye.
See ya.
Bye.